My name is Ezekiel Yorke, and today I'm going to give a brief 5-minute summary on how the Coanda effect affects or influences the Doppler imaging and color encoding, which is one of the forms of measurements to analyze heart disease. But first and foremost, what do we know about the Coanda effect in general? As you can see in the YouTube illustration, the Coanda effect is a hydrodynamic phenomenon in which a liquid adheres to a surface, be it a concave, straight, or convex-based shaped surface. It is caused by a shearing force, which then causes a turbulent flow due to that force. Unlike a regular pipe flow falling from, say, a tap, as you can see in the YouTube video, it causes an asymmetrical flow because of the disturbance due to the concave or convex-like shape. So we know what the Coanda effect is and how it behaves in general. But the real question is, what does it have to do with heart disease? It is to my understanding that using the information from this article, it wasn't until 1876 where jets of blood started occurring during abnormal conditions. For example, the double orifice mitral valve. This led to another occurrence or problem called the mitral regurgitation. Now this problem was where the heart's mitral valve did not close tightly. And then in 1910, when someone by the name of Henry Coanda observed jets passing from one section of the heart to another, it was observed that these jets would often stick or be pulled towards the surface or wall of any section of the human heart. This occurrence would then change the shape or make the flow of the blood asymmetric, which would then disrupt the flow as it passed from one section of the heart to another. This in turn gave rise to the Coanda effect. This then gave rise to the influence on the Coupler-Doppler jet area as well as color encoding, because there needed to be a way to measure or observe how the Coanda effect operated in the human heart. And the way in which the Coanda effect would be measured would then be called the color-Doppler flow mapping. Now, using the information from this article, it is to my understanding that this method of measuring or observing the Coanda effect in the heart had to do with the integration of color-encoded liquid. These forms of liquid would be composed of corn starched in water solutions. Using ultrasound, it would then observe the directions or flow directions of these liquid. It was clear to me from this article that a model was then devised that surrounded the color-Doppler flow mapping process. This model had to do with sending a jet through an orifice in which this jet would then be received by a chamber called the receiving chamber. The Coanda effect would then be observed. However, when observing the Coanda effect, 5 conditions were evaluated. It is to my understanding that the reason why these conditions were applied were to observe whether or not the jets coming from the orifice would be affected by the curved surfaces or straight surfaces, as well as how they would react compared to the 5th condition in which no surface was installed. Now, using the data that was achieved by the 2 observers, it was seen that the mean area of the control jet, that being the jet without any surfaces in contact whatsoever, had a larger mean area than those that came into contact with either the straight or curved surfaces. So through the observation of this chart, it was then clear to me that the Coanda effect in this experiment was determined by the proximity of the jet flow relative to the position of the solid surface, and 2, the type of solid surface that was used. It was also clear that there were some limitations that prevented more accurate results. The first limitation would have been the use of high flow rate. In this experiment, no high flow rate was used because it was seen that as the jet flow velocity increased, the jet area would also increase. This would then potentially prevent us from receiving data from the flow map if the jet area exceeded the boundary of the flow map. This then meant that a more effective approach had to be made, called the transvalvular regurgitant flow. This flow would then measure the jet flow in a 3-dimensional space. A source chamber in place of a receiving chamber would be used. This source chamber would then delete the use of an orifice. By extension, the flow velocity will decrease. This will lead to a more laminar, non-turbulent flow, in which more accurate results can be obtained. Thank you.